You ready for it? All right. Welcome to the second weekend workshop on Intro to JavaScript. I first want to go over the agenda we're going to be covering. I took a look at the comments from the last session and put an agenda together based on that. We're going to first go over some statements that we did not cover, that there was some interest in covering. That is switch or case statements, ternary operators, and for loop, other types of for loops. Then we're going to go do a retrospective on the to-do list that we did last week. And then we're going to take a look at patterns, and probably going to spend most of our time in that patterns category. Then we're going to cover node.js and take a look at how you can find some real-world examples to look at some more sophisticated code. So the first of the statements that we did not cover on the previous session that was requested was the switch statement. Question?
I clicked through the link that you had in the Slack.
Yes,
Oh, sorry, did you already talk about it?
No, I haven't yet. I'm going to get to that, but is it not working?
Yeah.
Okay, I'll be sure to, when we get to that point, I'll repost it. So to begin with the switch statement example, so let's go to JS Fiddle and take a look at that switch statement real quick. JS Fiddle seems to be not working for me right now, so I'll just stick to the slides. You guys can stay on JS Fiddle.
It sounds similar to Ifelse.
It is. Okay, so that's exactly what I was going to say. All right, so to me, this is just a different flavor of Ifelse. Some people prefer it. Some people prefer Ifelse. It's really just a stylistic choice. I prefer Ifelse. It just feels less complicated to me and more consistent with the rest of my code. But some people really like the way that this is structured. So in the case of a switch, you decide what variable you're doing a switch on, and then based on the value of that variable, you perform different actions, and you use the break keyword to get out of that action. Pretty straightforward. This is actually why I didn't cover it in the first session. I covered everything we needed to know. Almost every statement we're going to talk about right now is almost syntactic sugar. It's just on a very related note, the ternary statement. In the second line here, you see the ternary statement. It's really just an if-else on one line. So if the condition is true, it picks the first value. If it's false, it picks the second value. So if we ran this right now, we would get, we'd get morning. But it's really just another fancy if-else. The ForIn Loop is a little bit different. We took a look at how to iterate over arrays. The ForIn Loop is a way to iterate over objects. So unlike arrays, there's no index for an object. It's not 0 through x. It's key value pairs. So the ForIn Loop is a way to iterate over those key value pairs. You can if you have the JS Fiddle in front of you and you run it, there's a ForIn Loop for JS Fiddle. It'll print out the, it looks like it prints out the, it'll print out the values. So you can iterate through the keys, you can iterate through the values, you can use either the key or the value to do something interesting.
How would you be able to iterate through the property name and the value as well?
You can do, well, I mean, in a sense we are. So you iterate through the keys, and you can, if you notice that, second console.log in this example, it's accessing the property by the key name. It's not doing week.monday, it's doing week of Monday. You can do that in any JavaScript object. So that's how you actually get access to the values. So you iterate over the keys, but you still have access to the values.
Are we going to go over the difference with dot notation, bracket notation?
It's really that. I mean, it's really that simple. It's either when you have an object, you can access it by dot notation, or you can access it as sort of a key table hash. Okay, so like I said, we aren't going to spend a lot of time on those statements. They're interesting. You don't need to know any of those. You can write sophisticated programs without those, but they can be useful if you want to use them. So let's do a retrospective on our to-do list. So let me pull that up real quick. Let me delete all of this, actually. All right. So you'll notice we had that weird bug in the to-do list where the last item wouldn't go away. So that kind of frustrated me, and I looked at it after the last week's class, and I noticed that I had the click wrapped inside of my for loop. So it would this would only run, the HTML and the click would only run if there were items. So the second there were 0 items in that array, it would just like keep that button there because it wouldn't run through this. So I had to remove it outside of the loop, and I could get rid of this goofy if statement that we did up here. So the second I removed those events outside of the loop, it worked fine. This gets to a really important point, that loops are very error prone. You'll often find when you're writing loops that, oh, it went one over, or it wasn't one enough of what I wanted. Loops are kind of the way computers think. It's called imperative programming. It's not really the way we think about things. It's not intuitive. When I look at a loop, it's not obvious to me what it's doing right away. I have to stare at it for about 30 seconds before I actually understand what's going on. So a lot of the patterns we're going to look at are really about ways to make your programs more readable and therefore more maintainable. And getting rid of loops is one of those things. You need to understand loops to write programs, but you don't want to overuse them. And if you can find a more expressive way of writing something without using a loop construct, it is valuable. So, go ahead.
With the for loop, let's say, I know that anytime when you're doing a little statement, if you're iterating or adding to I,
Yes.
if you add more than one, sometimes it breaks the loop.
Yeah, or if you start at 1 instead of 0, or if you do less than or equal to, or you put the equals or the greater than sign the wrong way, it's very error prone. Loops are a common place to find issues.
Well, what I'm curious is, let's say we put I plus 2, right? And it will actually sometimes becomes a different loop, which I don't understand that.
That's,
because
yep.
I is less than to do items dot blank. You would think that if it's less.
Where this would become an infinite loop is if I put the greater than sign the other way, because it would never be, it would just keep getting greater and it would never be less than. But yeah, infinite loops is another loop situation. So let's get back to our slide. Sorry, let's actually take a look at the program. And there's one other thing in here that we talked about that I said I would cover and I did not. It's the keyword this. So what do you think this is here, just based on what it's doing? I don't want you don't need to understand the concept of this, but what do you think it's referring to? It's referring to an object. What object is it referring to? What ID am I looking at? Let's talk about this a little bit, and then maybe it'll make it a little bit more sense. So this is a reference to what is invoking a function. So what is it?
The coder invoked the function.
What do you mean by that?
Like, that you create a function and then you invoke it using something. Like, that's what I think. And I don't think objects invoke.
And most of the functions we wrote were sort of self-invoking. Here's an example of I'm creating a customer function, and then I'm creating a customer object, and then I'm attaching a login function to that customer object, and look at what is invoking that function. It's customer.login. So what would this be in that example? If I do console.log this, yep, exactly. Yeah, it's customer. Let's see if JS Fiddle's back up. And if you're on JS Fiddle, you can go to this example.
I think I have that terminology in my head because in lessons I've taken, I've said things like, and if you want to invoke this function, then you can put print or blah, blah, blah to then invoke. But does that
Yeah, invoking it just means calling it. Like, yeah, so an object can call it. It can be called. So we'll take a look at that. So let me see if this will run. OK, good. All right, so it is the object. This is my customer object. So what if let's create a login function that's invoked outside of that. OK. What the heck is that? Window. In this case, who's the caller? Yeah, it's not really an object. It's not connected to anything. Anytime you declare an object and it's not a named object, and it's a named variable and it's not connected to anything, it automatically gets attached to the global object, which is called window. Window has all sorts of stuff. So let's go ahead and open this up. It has all sorts of utility functions. Window is the global object. It represents the browser window that you have, so it has the properties of height, width. It has events like click, scroll. It has all sorts of information. And what I tried to post on the Slack earlier was this URL here. Is missing the first what?
you just selected it without catching the H.
OK. I'll put that in Slack real quick. Or if someone could just do that for me, that'd be great. So here's a reference for everything on window in there. You don't need to know all those things. You will never know all of those things. There's thousands of things that I've never even heard of on there. But it's a good reference to have. But that creates an interesting problem. So let's go back to our to-do example. I said before that every name variable that isn't part of an object gets hooked into that window object.
Does it become the name for the window object?
No, it becomes an object on the window object. So let's take a look at that. So this is a variable. Is that on the window object? It is. Yeah, it's global. Just to prove that, I'm going to do I'm going to jump outside of JS Fiddle because it's too slow. OK, here's our window object. What was our array called? Did I pass it? What's that?
It looked like it was an alphabetical order.
Well, it's an alphabetical order. It does properties. Oh, actually, oh, there it is. Yeah, to-do items. You see that array, how it's on the global window?
Yeah.
That's really bad, and here's why.
Don't do this.
When you execute JavaScript, especially in the web, there's usually many different scripts involved. We added jQuery right here, so that's a script. Here's my to-do script. Maybe this is another script that does something entirely different. So we'll call that otherscript.js. What happens if I do this in my otherscript.js? Yeah, so now what's going to happen? Let me try to, so I'm going to add something. Cannot read property push of null. So it's no longer an array that can do pushes and other methods that we had on the array. It's a null object. So I've now messed up another person's script because of something I added. So there's a little trick to make your scripts more private, and it's called a self-executing anonymous function. So let's make one of those real quick. So we wrap everything in parentheses. And then we make you'll remember earlier, functions create scope. So we're going to create scope and get it out of that window object.
So does the term anonymous function have something to do with keeping it from affecting other people's code?
It's anonymous because it doesn't have a name. I'll show you how and why it doesn't have a name. So I am creating a function. I'm not setting it to a variable. And then I'm invoking that function immediately after I create it. So it's sort of a one-time execution. It's not being stored in an object, and therefore it's not going to be on the window. So let's make sure I did that right. I sometimes mess up this syntax. And I did. OK, so I had.
Well, essentially what you're doing is you're putting it inside a function, therefore it's more localized, right?
It is more. It's more scoped.
Right.
Yeah. OK. So that to-do array is no longer on the window object. So I can do whatever I want in this other script, and it's not going to collide. This is becoming this is a very common pattern. It's very simple, but it's very powerful. In computer science, this is what we call encapsulation. So it's information hiding. And I think you were talking about this earlier as well.
Yeah.
You said a self-executing function.
Yeah, because I was running into issues when I was making Ajax calls. They just weren't syncing, right? Like my for loop was running faster than my actual Ajax call, so that's why I had to.
It was probably async, so it's probably a callback function.
Yeah.
A lot of callback functions use anonymous functions to pass in. We're actually going to get to that a little bit later.
And let's say in a working environment, in trying to keep control of how many keeping the global variables would be included.
Yeah.
How would all the teams would know what variables that they can't touch or they have to encapsulate?
So that's up to you writing the program to decide what you encapsulate and what you make available to the outside world. So in the case of jQuery, they intentionally made $ available. That's the only thing they put in the global namespace or global object. There's probably thousands of methods and variables in jQuery. They made it all private and then exposed just $. And we'll discuss how you can do that and why you want to do that.
So in a work environment, it's not like, hey, these are global variables you can't touch. And if you do, then it's somehow make it.
If something's in the global, if something's a global variable, you should be able to use it. Unless someone wrote a poor program and they stuck all of their variables and functions in the global variable, like we did, right? So we didn't write a best practice program. that to-do list would never pass a code review. We're now trying to get it closer to that ideal. But if something's in the global namespace, it should be accessible. It should be intentionally there. There's also a fiddle for that self-executing anonymous function. That's just a real simple example of creating a variable and showing that the variable doesn't exist outside of that self-executing anonymous function. OK. Next, we're going to talk about higher order functions or callback functions. They mean basically the same thing, but they have different connotations, and we'll discuss that. A higher order function is basically when you pass a function into a function. It's very easy to explain. It's very hard to understand. Previously, when we're working with functions, we're passing data as parameters. Now we're passing actions into other functions. It feels a little bit like Inception, like a function within a function. There's a fiddle for this. Let's go to it real quick. It's called higher order functions. Maybe. OK. All right, in this scenario, I just put an alert box as my function. I didn't write my own function. So let's take a look at what's going on here. So I have this array of numbers, OK? And I created a function called forEach, where I embedded my loop that's dangerous. And this function takes an array. So this is the data part of the function. And then it takes an action. And this is the part where I can pass in another function. So what this function does is it takes an array and does whatever I tell it to that array as many times as items are in the array. So theoretically, I don't need to use a forEach loop ever again. So here's an example of me passing the window.alert function into my forEach, which is why when I run this, I get the alert 5 times. OK. But this is reusable. Let's get rid of this forEach call or invocation, and let's make our own. So here I'm creating a function that's called add1. Should be called sum. Some values. So it's going to call that same forEach function and pass in another function to forEach the elements of that array. In this case, it's going to sum things. So let's see if I think it ran. Yeah, so it took every single element in that array, and this time it summed it. Notice I'm no longer using loops anymore. So this seems pretty reusable. Why don't I just always use this, or why is this not part of the language? Well, it turns out it actually is. So numbers is an array. I can do a forEach on an array. They built this into the language.
So it's not just jQuery, it's JavaScript.
So that wasn't jQuery. I built that on my own. That was just my own code. So let's get rid of everything here. And we just have an array, and then we're calling forEach on that array. So we're not writing that confusing while loop anymore. Or sorry, that confusing for loop. Does that make sense what's happening there? This is where it gets a little confusing, at least for me. It kind of reminds me of calculus, where you're passing functions into functions instead of linear algebra, where you're passing values into functions. But it's incredibly powerful, and it makes your programs a lot more readable and less imperative, more functional. Any questions on what's happening there or why that works?
Well, I had a question for each, and I put alert in, which is it's a function that it does something. If I put console.log, I get an invocation there.
Yeah, so you're using Chrome, right?
Yeah.
Yeah, Chrome has something goofy with console.log. I read up on it. It has to do with the implementation. It works in some browsers, it doesn't work in Chrome. And it's like just console.log that does this.
Is there a workaround or?
Yeah, create your own function
Oh, right.
that has console.log in it.
Gotcha.
So that's what's called a higher order function. So we've talked about sort of a more functional style of programming, which JavaScript, that's really kind of how it's built. It's meant to be functional. But you can also make it object-oriented. So let's talk about what is object-oriented programming. There's really three main tenets of object-oriented programming. Encapsulation, so that's that information hiding that we saw with the self-executing anonymous function. There's polymorphism, and there's inheritance. I'll go through each of these. So encapsulation, I think a television set is a great analogy for encapsulation. There's all sorts of electronic components inside of a television that I don't understand, and I don't need to understand them. I rarely have to go into the back of my television to do anything. All I need to know is that there's an on and off button, and there's a way to change channels. So if we think of the window global namespace, maybe you'll have a function called on-off for your television. Maybe you'll have a television object on there, which has an on-off button and a channel property. Everything else is hidden. All the variables and functions are hidden. All right, inheritance. In object-oriented programming, there is a hierarchy of objects. You may have an object called vehicle, which maybe has a property called can move. It's very general. It's very abstract. Then you get into wheeled vehicles, which may have a number of wheels. And then you get more specific into maybe car, which has mileage, steering wheel, has other objects. You don't have to define all of those objects in car. You can define them in higher up in the hierarchy so that it can be reused. So that may feel a little abstract, so let's actually take a look at an example. One more thing, polymorphism. As you get down into those more subtypes of classes, the same functions can do different things. So if I'm in a vehicle, maybe the sound is honk. But if I'm on a bike, maybe if I call the sound function, it's ring. Here's an example with shapes. Maybe I have this general abstract concept of a shape at the top of the hierarchy, and as I make classes that inherit from shape, the draw function does something entirely different for each subclass. Okay, so we just covered probably a quarter of computer science in 3 slides, so that's very abstract. So let's actually take a look at what that looks like in JavaScript. And before I do this, I will say JavaScript is not fundamentally an object-oriented programming languages. What we're going to see are kind of functional ways to create objects. So it's almost a workaround, and it kind of feels like a workaround sometimes. All right, so let's use our other script, since we know we can't break anything now. And let's use that hierarchy we saw on that slide. So let's create a vehicle. So notice there is a fiddle for this called classical inheritance, if you want to follow along. Or if you just want to type along, you can do that as well. So let's create what's called a constructor function. This is different than other functions. So we're going to use the convention is to use a capital letter for our variable name. Okay, and what can a vehicle do? It can move. We'll say can move equals true. We'll just put a property on there.
And you said this because you're referring to the object itself.
That's a great question. No, this is a special case of this. This is, I'll show you exactly what happens. Let's create this vehicle now. So we created a constructor function that represents our object. Let's now create an instance of that object. So I'm going to create a my vehicle equals new vehicle. New tells the JavaScript interpreter to pass my vehicle as a parameter into the vehicle constructor. So it changes the context of this to be my vehicle, and then so that's how it's setting those properties. So if that's a great question, let's do console.log here and see what is this. And let's first just make sure this works. So I've created a vehicle, and then I'm going to prove that it actually created and has this property on it, or has can move property on it. I need to be careful when I say this now. That's right. What's that?
It's kind of like JS Fiddle, but it mostly works on out of the console. It has its own console.
Oh, really?
Page.
I'm not even in JS Fiddle right now. I'm working locally, and I'm not sure why it's running slow. Okay, I broke a whole bunch of stuff here, it looks like. Oh, it can't reach jQuery? Okay, yeah, no, more internet connection issues. Weird. Okay. Let me get rid of my console.logs here just to clear things up. Okay. Okay, so it created an object of type vehicle that has the property can move. So that's not very interesting at all, right? So let's make something a little bit more useful. So we have this vehicle object. Let's create a car. And let's make a private variable, so we're going to use encapsulation here, for mileage.
So it's still a constructor then, since you have this.
Yeah, this is going to be another constructor function. And we'll set mileage to 0. Then we'll create a function on here called move. And as we move, the mileage will increase. Let's see here. So mileage equals that's the same as saying mileage plus 1. It's just a shortcut. Same as this. I'll do it that way so it's more explicit. And then I'm going to say, OK, the parent of car is vehicle. So there's this object called prototype on functions. Maybe I also want a method to view my mileage. And now let's new up a car. Before we do that, actually, something useful in constructor functions you can do is pass properties into the constructor function as you new it up. So let's put like make and model here.
Are you saying new it up?
Yeah, new it up, create it. So the new keyword. Good point. Okay, so I'm going to create my car. And then we'll log the my Honda to see. Let's call move on that object a little bit as well. So we'll say honda.move, honda.move again. And we'll also log my Honda dot get mileage. Let's see how much mileage is on it after we've moved it a couple times. Okay, so I did one thing wrong. I didn't invoke that function. Okay, so I moved the car twice, which made the mileage 2. Notice I can't set that mileage to 1. There's no way for me to do that using my Honda. Because this variable is private. These methods make it public, so I can move it and increase it by 1, and I can get it. I can't decrease it. There's no possible way for me to decrease it.
Right, because it doesn't have anything in it to actually.
There's no method that says -1.
Although it can't put a reverse right?
Right, exactly. So that kind of mimics real life. It mimics a real life object. There's things I can do to it. There's things that are private that I can't inspect or change. And so what we have here is sort of, we have inheritance, we have encapsulation. I talked about polymorphism. I could easily say this dot can move and change the functionality of that just by putting it in that function, because there's a prototype chain. I'll explain that real quick.
Functional programming languages have encapsulation, or is it just in order for it to be object-oriented, it has to have all 3?
All right, so that's a very controversial question. Object-oriented languages are based on those 3 tenets. Some do those tenets well, some do them poorly, or they do one aspect well and other aspects poorly. Functional programming in the strictest form is almost stateless, so it's almost the opposite of objects. If you look at our object, it's remembering the mileage, for example. So it's stateful, which is what makes it an object. Functional programming is a little bit less, it's more mathematical. There's less state involved. So it does things through function calls instead of keeping track of objects.
So there's no encapsulation.
But having said that, there is encapsulation because you can create private variables within functions. But there's less state.
Not sure I understand.
Yeah, encapsulation can be used for multiple things. It can be used for information hiding. It can also be used to create state. In this case, we're using it for both. Functional programming is more encapsulation, less stateful.
Let's remember that.
Yeah. This is something that makes my head spin a lot too. Functional programming is something it's something I've done a little bit of, and every time I do, I have to remember, look things up, and my head spins. But object-oriented programming is something I've done a great deal of, and this is one way that JavaScript implements object-oriented programming. Questions on this or what we see here, or what's happening?
Well, I tossed that log my Honda. What I returned back was the actual object of the vehicle with, with the make and the model.
Yeah, it should. So that's what I got too, right? Honda Accord.
But I got a little bit more. I actually had to move property and I had to get mileage property.
So that's interesting because we call that, right? We call move. So where the heck is it on here? How am I able to call move if it's not on that object? So there's something called a prototype chain in JavaScript, and this is kind of how it does inheritance. If it's not on the object that it's being invoked on, it says, okay, what's your parent? Checks the parent. Are you on that object? No, okay, check the next parent. Are you on that object? Keep going until it's at the top of the chain, and then if it's not there, it's undefined and it throws an error.
So that's why I got more, well, it's,
You probably just had yours expanded already.
yeah, it was
Yeah. So if we expand it, we see that it's actually the prototype is vehicle, and vehicle has can move. Any other questions on constructor functions and prototype chains? I'm asking this because these concepts will start to build on each other. And if you don't understand a previous one, it'll be more difficult to understand the next one. Not impossible, but more difficult.
So basically, constructor is pretty straightforward. Constructs the objects of the instances, and then prototype chains use those as our like a template.
Yeah. Exactly. That's a good way of putting it. And that becomes really valuable when you're writing large programs that have lots of data types that follow a natural hierarchy.
Right.
Okay, now let's talk about the module pattern. The module pattern uses a constructor function. It uses the this keyword. It uses information hiding, but it doesn't hide everything. And we'll take a look at what's going on there. So there is a fiddle for this called module pattern. Try to pull that up if the internet will let me.
I see one called module.
That works, yeah.
On page
It might be on the second page.
Can't read that blue text on there.
Okay, so you remember that self-executing anonymous function we had earlier? It's doing that to hide almost everything. Except at the very end of this function, it's doing a window.data access module and attaching just one object to the window. So this is exactly how jQuery works. When we had access to just $, jQuery has all of its private code, and then at the end, it attaches $, to the window. So it uses a module pattern.
So basically, the self-invoking, we created our data access module. That's a variable holds a method, right?
Yep, it has a couple of functions. It has get data or save data.
And then we don't really see that.
Yeah, so all of this, it's a self-executing anonymous function. So all of this is private, except at the very end, it puts everything it needs to do in an object and puts that onto the window. So now I can use this data access module and just use the functions I'm supposed to use. So in the television example, I have the on-off switch, I have the channel change.
Okay. So basically, it is the window object or the global object. You tack the data access module onto that.
Yep.
And we're able to see it now since we just threw it out.
Yep. And again, that's exactly what jQuery does. So when I use my jQuery script, at the very end, it attaches $. So I can use $, in any of my other scripts and not worry about variable collisions, because it's just that one object that I'm using.
Can we see that through jQuery if we look at the scripts on that?
Sure. So the jQuery source code is very dense and complex, but we can open it up, and we'll do that towards the end, because I'm going to show you how to look at other open source projects. Okay, so those are some patterns to keep in mind. Those are sort of foundational patterns. They are used in every single JavaScript program of size. As you start getting into 1,000 and 10,000 lines of code in JavaScript, you have to use those patterns or else it becomes the Wild West. So when I look at sort of hobbyist JavaScript programming and the leap to enterprise JavaScript programming, those are the sorts of patterns people are using, and you just need to know. Okay, now let's just talk about the browser and security. We're going to get into a conversation about Node.js and server-side JavaScript. So JavaScript doesn't have to run in a browser. When it does run in a browser, it's very what we call sandboxed. So it can't access my file system. JavaScript can't access my Outlook email. It can't access my databases that might be on my machine. And that's for very good reason, because if JavaScript could do that, you could visit a web page. They could have code that could say delete C, right? So it runs in this very strict environment. If you try to run, there's code in JavaScript you can run that accesses the file system and accesses other peripherals, and it will just throw a security exception. So like I said, JavaScript doesn't have to be run in a browser. It can be run really on any platform. And Node.js is a server-side platform that you can run JavaScript and have a lot more power. So let's start using Node real quick. Okay. What's the best way to do this?
Is there like an emulator online?
Yes. So you can.
'Cause I have a Chromebook, it's the whole end.
You should be able to. Yeah. Go to Google and type in Node download. You don't have to do it right now, but it's very easy to install. I have this program called, so I have this input file called input.txt. I just put some content in there. I now have this JavaScript file I called app.js. I'm going to run this in Node. I'm not going to run it in a browser. First thing to notice is this is called the file system module. In Node, when you import modules, you use require. So remember before how I said the module pattern? This is native to Node. It's built into Node using this require keyword.
So if we took a look at the actual package,
It's using an anonymous self-executing function that attaches its object, its very last object it wants to expose, to global.fs. It's not called window in Node. It's called global. So I'm getting that module. That module has a read file function that takes a callback or a higher order function. So I'm passing a function into a function. So that's something else we talked about. Here is the function that I'm declaring. I'm saying when the file read is done, if there's an error, just let the user know. If not, let's take the data and just write it out to the console. So this is my callback function. I'm passing that into the read file function of the FS module. So we have modules, callback functions. So let's actually run this in Node. So Node is installed on my system, so I can just do Node. What did I call my file? App.js. Let's run it. Okay. It logged out, welcome to Columbus Web Group Weekend Workshop. You would never be able to do that in a browser. There's no way it could ever read the contents of my hard drive. But Node has access. It's like any other server runtime. You can think of like Java or .NET. It has access to a lot more. So it could hit a database. It could hit a web API. Let's take a look at NPM now. So NPM is a way, so that FS module was native to Node. Let's say I want to use a module that someone else built. NPM is a way to go out and find modules that are open source on the web and pull them into your project. So I know there is a HTTP client called request. So I'm going to do an npm request. NPM stands for Node Package Manager. So I'm in the folder where my project is. And I forgot to do installs the command. npm install request. So it's going out to the internet. It's getting that module and pulling it into my project.
And what does that all mean, like that information? Obviously, that looks like a tree, so tells us what exactly is in the package. But like the package JSON.
Oh, what's this tree here?
Yeah.
Great question. Okay, so this is the beauty of Node Package Manager. To use require uses other node modules. Those other node modules might use other modules. So there's this dependency tree. NPM is smart enough to say, okay, I'm getting request. I'm getting this module. Based on its metadata, I need to get this one, and this one, and this one. If you look at this node modules folder, you see all the folders that request needs. And request should be in here as well. Yes, request is right here. Request needs all these other ones to function. So you can build really complex modules. You can build a module and sort of stand on the shoulders of all the other developers that have written modules to create really useful things. So now that I've pulled that into my project and that folder's there, I can simply do var request equals require request. Let's make sure that that's an actual thing. I'm going to run this. Oh, I don't want to run that. That would just do the same thing over again. Was it node app.js? Okay, so it's printing out that request module now. And if you remember, do you remember that HTTP request that we did in the browser where we went and got the stock ticker symbol?
Yeah.
This is the same sort of functionality. So you'll notice there's a get here. So there's a get method on that module. That's exactly what we would use to do that Google Finance call.
Okay. So it's like we're sending an internal AJAX request within the computer.
Yeah. And there are tons of NPM packages out there. If you go to Node's website, there are tens of thousands listed. So it's really easy to import those modules into your Node program. There's some for databases. There's some for web servers. It's a pretty active community developing modules. So it's still JavaScript, totally different platform, totally different capabilities, same concept. Same patterns, too. Okay, so we took a look at how we can kind of go out into the Node community and get open source packages. You can drill down into those Node modules folders and look at the JavaScript that's written for those Node modules. That can be a really great way to learn more complex patterns. However, you can do the same for your browser as well. So I don't know, has anyone here heard of Git before? Okay, it's becoming sort of the standard way to do version control. So if you download Git and install it, you can then go to github.com and view all sorts of JavaScript open source projects. Let's go to that real quick, actually.
Do you know about Free Code Camp?
Yes.
If you want to practice JavaScript.
Yes. Okay. So once you install Git, There's all sorts of categories here. So let's say, I think, is jQuery on GitHub? Yeah. So here's the jQuery project. Here is the URL to jQuery. So I happen to have jQuery or Git installed. So all you have to do is do a git clone and then whatever the URL is. It's now pulling jQuery from the internet through Git. So before, when someone asked, how do I find real programs and not look at these kind of contrived to-do lists and see how actual enterprise development is done, this can be a great way. jQuery is a really complex one, but there's other ones on here that are a lot more intermediary.
What are some intermediary open source projects that
Well, let's take a look here at some of the, we'll see all. Open data. Let's try this. I'm looking for less large organizations who have less developers working on their projects. So I was going into nonprofit and academic. So let's take a look at what this even is. I don't even know. Yeah, so they do some, if you'll notice here, they have some my internet's going out again. They have some groupings. So it's a good way to kind of explore and get exposure to frameworks that you may not have ever heard of. The ones that I've heard of are all very actively developed on and are therefore very complex. I can pull up jQuery real quick though. So here's what jQuery looks like. So all these functions and variables, this is not the whole jQuery.
That's strange though, because it doesn't look like it's in a self-invoking.
Yeah, I don't know. Hold on. Let's go to the actual. So I'm pulling it from its content delivery network online. So here you see the anonymous. So at the end of this, we'll see.
The parentheses that invokes it. You can close that.
Yeah. It does a couple things after that. But you see the beginning of it up here. So that's just kind of a good way to explore and find other frameworks. I wanted to summarize all of those patterns that we looked at. Just because there's a lot there, you won't understand all of them right away, but this is a good reference point to dig deeper. So we talked about self-executing anonymous functions and how that's a way to encapsulate your code and give it privacy. We talked about higher order functions and how it allows for more expressive code. It's less imperative, less loops. We talked about constructor functions and how that's one way to create objects and also create sort of object-oriented programming and inheritance. And then we talked about the module pattern, which creates encapsulation and hiding, but also allows for a public access modifier or a publicly available object as a managed entry point to your application. So after seeing all of that, what questions do you have for me?
I think with the module pattern, is it where it's an instance where you have to identify which objects or whatever containers that we have that will allow the user to control that?
Yeah, so that's a good question. Whenever you're doing something like the module pattern or object-oriented programming, you need to think about design. Like, what do I want my users to have access to? What do I not want them touching? What do I want to hide? So it's not so much a technical capability, it's more just a user, almost like a UX for programming capability. What other questions?
Meteor.js, I heard that the lead developer, like, I don't know, cracked the program or something, so.
Yeah, there's been a lot of, so I've never used Meteor.js, but yeah, there's been a lot of conversation about that recently. I haven't been following it. I've just seen some.
So just smart to go with Node right now.
I have no opinion. Trying to guess which programming language is going to win out is sort of like guessing the stock market or weather. You think something will make sense, and then for whatever reason, people go a different direction. So I don't like making those predictions. I use Node.js a lot. I really like it, so I will say that.
What about like Ajax? How do you, because for me, what I'm trying to understand is the callback with Ajax, how to control all your Ajax calls,
Yeah.
and how you can kind of keep it on the same pace as the rest of your code.
Yeah, so that is one reason to do a callback function. You'll notice in that read file function that I had in Node, I had that callback function. That function won't execute until the file's done. So if you're trying to like time it and do a while loop and hope that your while loop finishes before or after your call, that's the wrong way to do it. You need to use a callback function and say, I can wait 10 minutes if I need to. Then this code will execute. And that's when I say there's different connotations between higher order functions and callback functions. Callback functions are usually used when you need to wait. They both are functions passing functions. Callback is generally used when it's do a bunch of things and then call back to my function. Any other questions? I think there's a lot here. This is definitely probably 2 weeks of material, but there are things you need to know, and it should at least get you interested in digging deeper into those patterns. And at least when you see the pattern, know it. Like when you start using Node, like, oh, I know that this is a module. I know what a callback function is. Node relies on callback functions all over the place. So it'll at least give you the terminology to know what you're using. If you do have any questions later on, I'm pretty good about answering my email, probably within 24 hours. Feel free to contact me anytime, josh.harrison@improving.com. I hope you got something out of it.
I had a question that you were talking about. It's not like a technical thing. When you were talking about object-oriented programming compared to functional programming, thank you.
Yeah.
The analogy that popped into my head was like theoretical physics.
Okay.
I don't know if that's a good analogy or not. I Googled
In,
it real quick.
in terms of functional?
Yeah.
So
yeah.
theoretical, I don't know about theoretical physics. I will say physics is very much based on calculus, which is functional programming, right? You're
Right.
passing functions into functions.
Right. Yeah, and I was thinking theoretical physics only because something I saw online was, folks were using algebra,
Mhm.
geometry. You sort of mentioned this too, to build things and to,
Yeah.
very state oriented. But then Newton created calculus in order to manipulate and predict these things that are not like a ball that you can throw.
Right. Yeah.
go 5 feet. It's like, or building you could build. So I don't know.
It feels like theoretical physics, at least when I'm writing programs. I always think I understand some of these concepts, and then like I realize, oh, I didn't quite understand it well enough.
Yeah.
But I'm like always thinking that. Like I'm always getting a little bit closer, but not ever grasping it 100%, which is also kind of fun. It'd be boring if I just understood it all right away.
Right.
All right, I'll be around afterwards if you guys want to ask questions. Thank you, and thanks Columbus Web Group.